understood the concept of the difference between the mass and weight of the body, now we can proceed ahead to understand the center of mass, center of gravity and the centroid of the body. Let's understand these three concepts. Students, basically when I say center of mass, it is nothing but what? Center of mass is a point somewhere on the body where the entire mass of the body is said to be accumulated, isn't it? So if I take a body, let us say I take a rectangular body here. Let's take a rectangular body. So it will have some matter, isn't it? So the center of mass will be a point where the entire mass of the body is said to be accumulated. So let's call this point as the center of mass. So it is nothing but what? It's a point where entire mass of the body is accumulated. Now students, once I have understood what is the center of mass, let's try and understand what is center of gravity. Now this one concept should always be remembered very properly. When you say center of gravity, students, it is a very important concept. The reason for this is, for instance, if you want to design, say, a vehicle, then it becomes very important to find the center of gravity of the vehicle. The more closer it is to the ground, the more stability you will be getting to that particular vehicle. If you observe the Formula racing cars, they are very close to the ground. The reason for this is you want to keep the center of gravity very close to the ground so that you get more stability. The more away the center of gravity from the surface, then you will find that you will not get stability to that particular vehicle. So finding center of gravity of vehicles becomes very important. So there are many applications of finding the center of gravity. Students, now let's understand what is center of gravity. Now as I said, that the weight of the body, isn't it? Weight of the body is nothing but what? It is the force that is exerted by the body on the surface. Now similarly, I can say the entire weight of the body will also get concentrated or accumulated at one particular point. That point is called as the center of gravity. Now students, I want you to go and do some research work on center of gravity. You can go and Google this one particular toy which is called as a flying eagle. Now go and search flying eagle toy. You'll observe that this flying eagle can be balanced on its beak. So the span of the wings is arranged in such a way that the entire toy, the entire flying eagle can be simply balanced just on its beak. So that beak becomes the pivot point. So when I say pivot point, it is nothing but the center of gravity, students, isn't it? So center of gravity is basically what? It is the point where the entire weight of the body will get concentrated or accumulated. Now, when you keep the gravitational field uniform, if the gravitational field is uniform throughout the body, then the center of gravity and the center of mass are one and the same points. Now students, you can observe that human body is symmetric, isn't it? Now if you take the human body, it will get divided into two equal parts, isn't it? If you take a line of symmetry, then you will find on the left and on the right, the body is divided symmetrically. So you can be rest assured that the center of gravity will be lying somewhere on the line of symmetry, isn't it? So now you can say that the center of gravity is nothing but a point where the entire weight of the body will get concentrated. You must have seen some students usually balance a book on their fingertip, isn't it? Or you must have seen in football, the ball gets balanced on the fingertip. So it is nothing but what? This is nothing but balancing the entire weight of the body at one single point. That point is called as the center of gravity, and center of mass and center of gravity are one and the same points unless and until you are keeping the gravitational field uniform. So if you keep the gravitational field uniform, then you can say that the center of mass and center of gravity are one and the same points. So students, here I am telling you that the gravitational field is kept uniform. So here I am going to write uniform gravitational field. Uniform gravitational field. So when the gravitational field is uniform, at that time you will get the center of gravity and center of mass at the same point. So this is center of gravity. It is basically nothing but a point where entire weight of the body is concentrated. Getting or not, students? Or you can say accumulated. One and the same meanings. Now, we have understood what is center of mass, isn't it? Center of mass, point where the entire mass of the body gets accumulated or gets concentrated. Then we have seen what is center of gravity, a point where the entire weight of the body gets accumulated or concentrated. Now, let's try and understand what is the centroid of the body. Now, students, centroid is basically the geometrical center of the body. That's all. A centroid is nothing but what? It is the geometrical center of the body. So if I want to tell centroid over here, it is nothing but the geometrical center of the body. Now, can I say geometrical center of the body? Now, can I say that the centroid will also be at the same place? Students, again, there are two very important conditions to tell whether the centroid also lies at the same place. If these two conditions are satisfied, then you can definitely say that the center of mass, the center of gravity, and the centroid are one and the same points. They all will coincident. They will be all coincident points. Now, students, centroid I have understood it is the geometrical center of the body, so it's a rectangle. So definitely here the gravitational field is kept uniform. And the second condition, homogeneous material. Homogeneous material. Now when I say homogeneous material, what do I mean by this? I simply mean that density of the material is constant. Density of the material is constant. That means the entire material has to be of same density. Let's take the example of a hammer. Students, if you take a hammer, you already now can visualize how the hammer looks like, isn't it? It has a heavy metal piece, isn't it? It has a heavy metal piece, and then to hold that metal piece, you have a wooden stick, isn't it? Wooden rod, you can say, a cylindrical wooden rod is there. Now, if you separate these two and you weigh them separately, where do you find more weight is there? Whether the iron piece is more heavier or the wooden piece is more heavier? You will definitely observe that the iron piece is heavier than the wooden stick, isn't it? So students, I'm going to make a T shape over here. The hammer is actually a T shape, isn't it? A hammer is a T shape. So let's draw a T shape over here. Now, what I'm going to do here is I'm going to take the metal piece over here. This is the metal piece, iron piece, and then I have a wooden piece over here. A metal piece and a wooden piece. Now, obviously, if you want to get the center of mass, students, it is a matter content of the body, and the matter content will be accumulated at one particular point, that is called the center of mass. So here, if you are keeping the entire body in uniform gravitational field, then the center of mass and the center of gravity will be exactly at the same points. So let us say the center of gravity will be somewhere here. Getting or not? This is the center of gravity. Now students, the density is different for both the materials, isn't it? Here the density is more, metal has more density than the wood. So the geometrical center will be different than the center of gravity in this case. The geometrical center actually will come somewhere here. Now you'll be solving such kind of questions where you want to find the centroids of different bodies of composite shapes. So this particular point is called as the centroid. This is the centroid. So it is basically what? It is the geometrical center of the body. That's all. Centroid is the geometrical center, whereas center of gravity is the point where the entire weight of the body should get accumulated. So you can remember the example of a hammer. It is the best example that you can remember for difference between the center of gravity and the centroid of the body. So remember, center of gravity is a point where the entire weight of the body will get concentrated. You can balance the entire body on that particular point. Whereas centroid is nothing but what? It is just the geometrical center of the body. So remember, center of mass, center of gravity and centroid, they can be one and the same points provided the entire body is kept in uniform gravitational field, isn't it? And the second very important concept is that it should be of homogeneous material. That means the density of the entire material should be same throughout the body. So if these two conditions are satisfied, then you can definitely say that center of mass, the center of gravity and centroid will be coincident points. They are all one and the same points. Otherwise, these points are all different points from each other. So students, that was all the concept of center of gravity, centroid and center of mass. Now let's proceed ahead with some standard shapes to understand the centroid. Now remember, in our syllabus, we always have to assume that the material is homogeneous and it is kept in uniform gravitational field. That means the centroid and center of gravity of the body is going to be one and the same points. So in the question, whether it is asked to find the centroid or it is asked to find the center of gravity, it actually means the same thing. But remember, they are both different concepts if the gravitational field is different or the density of the material is different. So students, now let's proceed ahead where we will be learning the centroid or the center of gravity of standard shapes.